Well, she says it's on. Okay, well, can anybody not hear me? Faye can hear me? She's going to be my gauge way in the back there. All right, so this next section is meant to just introduce some of the terms and standards so that when Brady goes through the transition plan development after the break, you understand what he's talking about. All right, so we're in section 2, and we'll just get started. So the things that I'll talk about mostly are something called the pedestrian access route. The pedestrian access route is the continuous corridor that must provide access from destination to destination for any person. All right, so when I use the word PAR, Brady uses the word PAR that stands for pedestrian access route. We'll also I'll introduce the curb ramp requirements and talk briefly about accessible pedestrian signals, or APS, and then we don't really cover alternative pedestrian access routes, but at the end of my sections, I'll make sure you know that those standards are listed in the MUTCD. MUTCD. So we'll have a separate class on construction requirements where those standards and layouts are very exhaustively covered. All right, so here's a PAR, a pedestrian access route. It reminds me a little bit of a Family Circus cartoon where Jimmy or Billy, whatever little boy that is running all over the place. But as you can see here, this clearly defines what we're talking about. So destinations are important. If there's no destination, you don't need a PAR to it. Okay, so every square foot of park or field or community doesn't need to have a pedestrian access route, but if there is a reason for a person to get there, a destination that's a public destination, then it has to be provided with clear access. So we're talking about bus stops, crosswalks, aisles in handicap accessible parking, and the aisle has to provide access to the PAR. We're talking about buildings and doorways and leisure areas, and all of that has to provide access. So I use the word corridor. I teach Civil 3D here at the university, and when I think of a corridor, I think of a three-dimensional kind of a corridor, or a tube, or a protected area. I think that's a good visual because we're not just talking about the flat surface, we're talking about the width, and we're talking about obstruction-free. So as I talk about the PAR, this is what we're covering. The PAR has some critical components. Pavement surface, starting literally from the ground up, pavement surface is important, as is the width, okay? No obstructions, but it also has to provide adequate width. Also, the slopes have to be such that somebody can navigate the PAR without having challenges. So we look at the cross slope. I use the word transverse slope or perpendicular slope. And for me, there's lots of people using the PAR, but the one we use as a design consideration and for laying out this class is a wheelchair. So clearly there's going to be people with canes and other assistance types of tools, but for us we're talking about wheelchairs. So when I say perpendicular to the wheels, I mean the wheels on a wheelchair. Running slope is the slope, I might use the word longitudinal, that's the slope in the direction that the wheelchair would be traveling. Remember when a wheelchair comes up to a pedestrian curb ramp, they're going to turn, and so likewise that running slope turns with them. One big challenge in designing a PAR is when you get to an intersection and you have a gutter. So gutter grades have both transverse slopes and longitudinal slopes. So in the gutter, traditionally we'd have a 6% gutter slope. When we get into a PAR, it has to be flattened out. I will talk about the maximums when we get into it. They're pretty easy, but intersections pose all kinds of flattening requirements because now we have people traversing through them. Crosswalks and intersections go hand to hand. Brady kind of introduced us to the idea of accessible parking. We'll talk briefly about that. More and more now, public right-of-way includes stairs, ramps, areas where people kind of enhance the intersections to invite people in for things like farmers markets and fairs and all kinds of activities. I mean, just driving around, Brady and I both happen to live very close to each other out by Plymouth and Wayzata. You know, lots of intersections are being upgraded to invite people in, and when you invite people in, now you add appurtenances and you add considerations for accessibility. Landings, nobody will leave today. Nobody is going to go to lunch without knowing what a landing is, because that's a big part of the PAR. A landing is a place where you provide refuge, provide a place for people to turn. It has to be flat-ish, 2% no maximum grade, not flat, and also has to be of a certain dimension. All right, so let's start with the pavement. Pavement surface has to be firm, stable, and slip resistant. Here's our most, which one of these is the arrow?
The big circle.
The big circle? Ooh, there we go. All right, so here's our most common type of pavement surface we're going to see in a PAR, which is a sidewalk. This happens to be a concrete sidewalk, but concrete is not specified. It doesn't have to be concrete. In fact, over here we have a bituminous trail, which would meet the requirements of stable, firm, and slip resistant. As I mentioned in that video with the woman, with the cane, I could just imagine her walking down this sidewalk, keeping her cane or keeping her foot in that longitudinal joint. Again, lots of times we don't have any longitudinal joints in sidewalks, especially if it's a 4x4 or a 5x5. But just now, thinking about how somebody might navigate, even hitting a transverse joint would tell them that they are on the right course, right? Transverse joints provide an opportunity for us to be out of compliance on the PAR. We'll talk about that later when we talk about vertical deflection. But these joints can't pose a tripping hazard. So somebody needs to be able to traverse through there without having a joint that's too wide or has too much differential movement and poses additional challenges for them. Over here we see a lovely bituminous trail. I'm a pavement engineer, so I know eventually this thing is going to crack. Bituminous paths and trails offer an additional kind of stress for us and for the pavement. Haha, that's a pavement joke. Anyway, because the joints on a bituminous trail, depending on how wide they are, have a great opportunity for getting even wider, right? So concrete pretty much won't, I mean, it is uncommon to see a concrete panel that's cracked mid-panel, but bituminous trails are going to get transverse joints, and because of the nature of bituminous, they are going to open wider than a concrete joint. The maximum width on a joint is a 1/2 inch in a pedestrian access route, so that's a whole different deal when you're talking about maintenance. Also, if you allow for any secondary cracking, we could get to the point where we maximize or we meet or exceed the 1/4 inch differential in longitude or in surface elevation. So bituminous trails offer their own kind of maintenance issues when they fall in the PAR, which they do, because that's why we have them. Over here we have another kind of pavement surface which is totally okay in the pedestrian access route as long as it is stable, firm, and slip resistant. So here we have a boardwalk. That one looks like wood. You might also have a Trax or a plastic or a composite type of product. Totally okay, but we have to do some things. We have to make sure that there's barriers that make sure somebody doesn't walk off there. We have railings and handrails, all that for safety. But in the PAR itself, have to make sure that the boards are closer than a 1/2 inch apart. Also, with this kind of surface, you might get some kind of heaving of a board, and it might throw you out of compliance because a vertical deflection of greater than a 1/4 inch is a tripping hazard. Over here we have gravel. Totally okay, as long as it is stable, firm, and slip resistant. So once you get gravel, it starts to be washboarded, or you have some bird baths in it, or other things that would be not something that is stable, firm, or slip resistant, then it needs to be maintained or graded so that it is acceptable in the PAR.
Excuse me, sometimes you get greater than 1/4 inch deflection on a gravel road though.
I know.
So
So that's a problem.
presents an issue.
Well, yeah, I mean, I'm thinking of, on a gravel trail, that's different than a gravel road, although if your road is the only corridor between destinations, I suppose that becomes part of your PAR. So watching for those localized bird baths and low spots would be something that you'd have to add to your list of maintenance checks. 1/4 inch is pretty shallow on a gravel surface. That's a piece of aggregate, right?
Yeah.
So we have to think about, obviously that's ridiculous, but I think the overall idea is a change in the surface, et cetera. It's a surface itself of a 1/4 inch. Do you want to add anything to that?
And chances are, if that gravel road has that kind of deflection, it probably violates one of the stable, firm, and slip-resistant requirements. You'll hear us say that a lot if you haven't already. So, and then the other thing is that 1/4 inch vertical deflection can increase to a 1/2 inch if there's a bevel, like a 1 to 2 bevel.
Yeah, so then we're going to get out there and survey our bird baths, make sure we have the one. I think the overriding idea here is gravel would not be my first choice, but if I have a trail that's gravel surfaced, I think requirements of the PAR, but clearly gravel has its own set of challenges. Let's see, the next one. We're in the metro area, so maybe some people are going to raise their hands. Who has some cobblestone in their jurisdiction? Yeah, where are you from? City of Minneapolis? St. Paul? Faye, City of Minneapolis?
St. Paul.
St. Paul?
Minneapolis.
Minneapolis? Yeah, so believe it or not, there's still cobblestone around. I drive over it as I get to the U down Main Street by River Place, but this is not an optimal surface for a sidewalk, obviously. Because we have those joints that are now greater than a 1/2 inch. We have vertical deflection, which could be easily greater than a 1/4 inch, and we just know intuitively this is not a place that we want somebody in a wheelchair to be because their wheels could get caught. It's a bumpy ride. Somebody who's visually impaired is going to have their cane get stuck in there. So, but it's not to say that this is something you got to go out and rip out all your cobblestone, right? So we're here to tell you optimal surfaces. Everybody's got stuff to deal with. That's the beauty of being in civil engineering. So we hope that as you have challenges that come up today, you bring them up to me and Brady. Who's got something that looks like this? Anyone? Yeah. Hands up. We all have cracks and heaves in our sidewalks, at our intersections, a pretty common thing. And again, requiring our note and attention that this throws your PAR out of compliance by the letter. 1/4 inch is pretty easy to get a transverse deflection, or I mean a vertical deflection on a transverse joint, not an uncommon thing. Outstate, I forget where we were, Detroit Lakes and Brainerd, they talked about having a contractor who will come in and hack these things off, kind of with an angled saw. I've been doing pavement stuff for years and I was not aware of that. I'm seeing a lot of nods. So that could be an adequate repair here. Also doing a patch, which meets the bevel requirements that Brady talked about, is okay. This is going to start to be a problem too when you have other types of pavement distress in your PAR. It just becomes a problem from both the opening size of a 1/2 inch and the vertical deflection of a 1/4 inch. Here we have a hint that we have some ponding or some settlement issues at the bottom of our pedestrian access ramp or pedestrian curb ramp. The reason that's a problem is this indicates water. You can't have ponding in your PAR. So we talked about surface, now we'll talk about width. Brady already talked about ProWag having a minimum sidewalk or a minimum width requirement of 4 feet. MnDOT elevates that to 5 and even prefers a 6. So clear width must have a minimum of 4 feet. And MnDOT allows, when we go through the standard plans after lunch, MnDOT does allow you to go down to 4 in situations where you don't have any other options. So I think 4 feet is kind of our bare minimum. This becomes a challenge sometimes, especially when you're in a commercial district. So now I'm expecting a lot of hands. How many of you have commercial districts in your jurisdiction? Lots of you, right? So when you have lots of doors, you have stairs and ramps, all this stuff kind of infringing on your pedestrian access route, we have to still maintain that 4-foot width. So we'll talk briefly about doors, not too much, but that is part of the consideration. If the clear width is less than 5 feet, then the standards require you have to have a passing zone every 200 feet. What is a passing zone? This is not like a little bump out with signage that says passing zone. What it is it has to, your sidewalk or your par has to allow for this additional width within a 200-foot limit. So Brady and I worked on the University of Minnesota's evaluation, looking at every square foot of concrete sidewalk, which was millions of square feet. And we found that the U, this is one thing the U met without any problem, because within a 200-foot linear distance, even where they had sidewalk that was less than 5 feet, there was usually a door to a building or a widened section or an intersection. You know, just think about the U. There's like plazas all over the place. So this is not a problem at the university. It might be a problem on a city street where you have a block that's 300 to 400 feet long. If you don't have any wider section mid-block, you might have to allow for a passing zone. Has anybody ever heard this requirement before? A few yeses? Okay. Over here, we have lots of fun conversation about this. This is clearly not within the requirements of the pedestrian access zone width of 4 feet. So that's okay. If, in fact, there's something like across the way or across the street that would provide somebody in a wheelchair to get to a specific destination. So assuming that there's a reason to get to the other side of this block, I mean, people live there, so we can assume that. The fact that this may or may not even be a sidewalk, it might just be paved area adjacent to a building, is not it's not a deal breaker. We see there's a sidewalk across the way. If this is part of the transition plan, the engineer or the planner might say, this is going to become our par when we redo this road, and this sign is going to get relocated so we can maintain that zone width through here. This driveway is going to get redone so that we can maintain the cross slope, and that becomes a viable alternative. So our message today is every pavement surface does not have to be within these standards, but you have to provide destination access from one point to another. Faye, do you have a question?
Yeah, is that because there's a protrusion or an obstruction?
Well, it's because that this doesn't meet criteria.
That you don't have to provide access on that side of the street?
You don't have to provide access on every side of the street, you just have to provide access. Isn't that correct, Brady?
I'm waiting till I turn my microphone on. What the ADA says is that whatever infrastructure is there has to be accessible. Now, if there is an adequate route, it's a little bit gray. But there's an adequate way to get from one end of that street to the other. It doesn't have to be right here because the cost of removing that pole to make it accessible might be enormous. I don't really know. In this specific case, it might be a better option to just make sure that that other side is the accessible route. This picture is just trying to indicate that that doesn't meet the requirement for width. And then so that's what we originally intended it to be, and in every class we've gotten into a long discussion about what's going on in this picture and how you'd fix it. But
or if you even have to fix it.
Well, so actually, I mean, the question I have is actually T intersections, which is where we have been wrestling with. So if you have, a car on one side of the street that you're not providing programs at every T, are you saying that that's in compliance because you're allowed to traverse one side of the street?
So Faye's question was, at T intersections, if you only, so let me know if I'm inferring this correctly. So let's say you have a roadway that has sidewalk just on one side of the street and there's a T. Do you have to provide access perpendicular even if there's no pedestrian access road on the other side?
No, there could be a sidewalk on both sides.
Okay.
You have to have curb ramps getting across the T intersection.
You have to have curb
Yeah.
ramps across the T intersection.
Across the top, in other words. Not across the stem, but across the top, to connect to the other side of the T.
Yes. In short, yes. If I understand it right, there's a walkway on the, like let's say it's the south end of the street, and then a walkway across the north end on the other side of the street. So you're wondering if this piece has to be provided?
Yep.
Yes. Because that would be the logical destination of that walkway, right? Feel free to talk to us afterwards if there's more to it.
Another thing that came up was that, I mentioned it earlier, this may not in fact even be a sidewalk. At the university, we could go on a little field trip and see lots of areas where they pave right up next to a building just for maintenance issues. It'd be hard to get a mower in here, or if you had gravel in there, it'd be difficult maintaining. So then the next question is, well, do not sidewalks have to be labeled? This is not a sidewalk, or does there have to be other types of guidance? And the conversation has clearly been, we don't want to advocate excess signage, or no, things don't have to be signed. This is not your entrance. The entrance is over there, etc. So within a context of common sense, this may or may not be a sidewalk. It looks like behind her there's another guy wire and there's additional stuff throughout. It just is an example. We understand that all of us in this room that are interested in civil engineering and construction and planning have to deal with the earth and the world, which has been constructed long before we were. So there's lots of stuff out there that's not compliant, and dealing with it is a challenge almost at every intersection, right? So we'll continue talking about the requirements that I'm sure will pose other questions and challenges for you as we keep going. Here's one that'll provide lots of challenges for you, especially if you're from Red Wing or Winona County or Duluth. I can't wait till this week when we talk to the guys in Duluth. The maximum running slope, in other words, the slope parallel to the direction of the wheelchairs, is 5%. All right, now lots of roadways. Who here has a road in their jurisdiction that has a longitudinal grade greater than 5%? Quite a few of you. So even you're in Cottage Grove, right? So even somewhere you might not even expect that, going down to a river area or a park or something, you may well exceed 5%. MnDOT lets you go up well beyond that. If there's a sidewalk adjacent to a roadway that is greater than 5%, then you can not meet that standard. So there's room in the guidelines and standards for deviating from this if your design is such that it just can't happen. So for example, if you had a road at an 8% grade, there's no way that you would ever make up that change in grade over the length of a block that would allow you to put in like anything other than a switchback or an elevator at the end of your end of your sidewalk, right? So that's just not mathematically possible. So we are going to not worry about those cases. We're going to focus on where we can meet 5% or less, and that's our maximum longitudinal grade. Anywhere anywhere that you have a longitudinal grade or a running slope greater than 5%, that's considered a ramp, and must have landings and handrails. When we go through the MnDOT standards for curb ramps, you'll see that the maximum on the curb ramp is 8.3%. A curb ramp is not considered a ramp that requires handrails. If it was, we'd go broke putting in handrails at every intersection. So at a curb ramp, you do not need handrails. But if that ramp was somewhere at an independent alignment, in a park, at a building or something, then when you exceed that, you need to have handrails. This shows our first landing. Whether this is we're not calling this a road because we know that would be impossible to build, but a landing is this area that's required every time we have a slope greater than 5%, you have a elevation change greater than 30 inches, you have to put in a landing. The landing has to be at least 4 by 4 with a 5-foot sidewalk. It would be 5 by 5, and the maximum grade on a landing is 2% in any direction. When we get into the pedestrian curb ramps, you'll see lots of landings because those are required at the top of that 8% slope on a pedestrian curb ramp detail. So when we get to that, we'll talk about it in more detail. This is a driveway. This indicates that even through a driveway, we have to maintain that longitudinal maximum grade of 5%. So if you were coming in through here and you had to go down to meet gutter grade and the grade exceeded 5%, we have some options. You can provide an offset driveway or some other driveway options that allow you to stay within that standard. We'll talk about driveways too. Cross slope, that's the transverse slope or the slope perpendicular to the wheels, and the maximum cross slope is 2%. Actually, if you get your calculators out, or maybe you're really good at math in your head and you do 1/48, you'll find that that slope is actually 2.08. We have a bounding agreement in this room that we don't tell contractors that. We stay at the 2% because that gives us a little bit of fudge with the contractors. They can actually go up to 2.08%. But our message is 2%. That gives them a little leeway. The standard is actually 1/48. We had one contractor in our class so far. Any contractors in here today? Oh, good. We don't want to let out any of our secrets. We had to bind and gag him a few times. All right. Just kidding. We really didn't. All right, accessible parking lots. Brady talked about this a little bit. We have to provide reserved parking stalls. We have to make sure that the aisle makes sense. Now that I've told you this, start looking around, especially this week as you finish up your holiday shopping. Lots of access aisles don't make any sense, and they throw the people in a wheelchair out into the parking lot. My dad was in a wheelchair for a long time, and it's crazy what people have to put up with if this is not well thought out. So the aisle has to provide access. Think about the design of your parking lot. This is the cross slope on the aisle. That also has to be maximized at 2%. So if you have a parking lot that has a longitudinal grade greater than 2%, on the edges where you have these aisles, you have to do a little bit of warping in order to maintain that cross slope. Do you understand what I'm saying? So we got no more than 5 in this direction, no more than 2 in this direction. Oh, great. See, he's going to correct me, and that's totally okay. I have no ego.
It's
I don't.
Anywhere in the aisle or the accessible stalls, it's a 2% max in any direction.
Oh, that's right. It's treated like a landing. Yep. And I knew that, and I misspoke. Sorry about that. Oh, and it has to be connected to the PAR. So again, it has to provide access. We have a 2% slope in any direction, even said that on the slide, and it has to connect through without throwing people into an unsafe situation. Now, there are situations where they would have to navigate through the parking lot just because of the geometry of the parking lot. Then the maximum grade still has to be 2%. Intersections and crosswalks. This is just a picture of a very beautiful intersection. Our standards are significantly exceeded here. So we have crosswalks that are discernible through contrasting colors. We have refuge areas. We have accessible pedestrian signals, all kinds of features that we don't necessarily always have. Here we see some additions. We don't have domes here, but we do have some kind of pavers or stamped concrete. This looks like pavers in here that provide just a kind of refuge area. Not required. What is required is access through. So this is a diverging diamond intersection, and believe it or not, there's access through here. We don't see beyond the slide, but there's obviously a place of business here, presuming that these pedestrians would cross down here somewhere, come through, walk through here, and now that I've taught this class, I have looked at several diverging diamonds, and that is where the pedestrian access route is, right through the middle. Anybody familiar? And then crossing, 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 and then we're assuming this is going to be under construction next year to provide additional access, because there's nowhere for them to go. This is my clue to stand right here and talk about. Access must be provided through an entire intersection. So, good example till the very end over here on Dolores Drive where we don't have access. Just a few more things to point out. We'll talk about these truncated domes and where they sit, where they're supposed to be, and they're pretty confusing because we got all kinds of geometry at intersections. So what are the rules for where they must be placed and how they must be maintained? Over here we have a nice crosswalk. We see domes back here. We see the curb cuts. Here we even provide an area of refuge that might be acceptable for somebody who's walking, but for a wheelchair-bound person, that's really not big enough. How many of you are having stamped concrete anywhere in your jurisdiction? Yeah, I know City of St. Paul has lots of it. Because we had people with cobblestones, we kind of jumped over the whole paver conversation. We'll talk about pavers throughout class today, and the fact that they may not be a very good choice in the pedestrian access route because pavers can easily start to deflect. You could have localized heaving that would exceed that 1/4 inch. They provide a tripping hazard, even for walking people. We might have them open up or have one paver just simply fail and have to be replaced. So pavers are not optimal in the pedestrian access route. There's lots of pavers, I'm sure, in your jurisdictions because we're in Minneapolis-St. Paul area. Whether they're going to be allowed in the future is something that we'll discuss. Another thing about crosswalks and intersections, Mindy, you want to get him a book? Here we show a nice refuge area in a pork chop or in a free right. So again, we have the domes, we have the crosswalk. The domes are clearly delineated because they're of a contrasting color. They seem to cover the entire width of the par, and we'll further talk through those details later on today. Doors and doorways. For most of you, you have your pedestrian access route runs through a commercial district somewhere, and you might have doors or doorways that are something you have to be considerate of. The accessibility code provides guidance for that, but our main overriding principle is that the door cannot protrude into the pedestrian access route. So you have to have some kind of frontage zone, a clear zone where you still maintain that minimum 4 foot, optimally 5 foot clearance through area where people aren't going to be hit by doors. It also provides refuge for the person using the door. So as they're approaching the door, they're not blocking somebody in the pedestrian access route, and they have room to back up and let the door swing open. Stairs and ramps. Already talked about, if a grade is greater than 5%, it's considered a ramp. Unless we're at a curb cut, you need to provide a railing at that location. Landings, these areas that are 2% max grade in all direction, must be provided where you have a vertical elevation change of 30 inches. So depending on your running slope, that's going to change locations, but you need to provide that resting area every 30-inch change in elevation. Just like I mentioned before with the picture of the boardwalk, you have to provide edge protection. Here's the handrails. Still must maintain a width through the entire ramp or staircase area. And then likewise, we're also still going to be concerned about those vertical discontinuities, longitudinal or transverse joint openings no greater than a 1/2 inch. And we have to still be stable, firm, and slip resistant. Excuse me. So again, when I look at this picture, I don't know where that is. Anybody recognize it? I always think of Golden Valley, where I go to get my license tabs renewed, and now all of a sudden there's all this new bus stop area, and there's a farmer's market there.
It's in Maple Grove.
Oh, this is in Maple Grove? Okay. But that's a pretty familiar kind of thing that lots of you are dealing with now. So where you might not have had stairs to worry about before, now you got stairs, you got ramps, you got, bigger, wider areas where you're going to have geometry challenges that maybe are different than when you have just longitudinal or transverse changes in direction. There's standards for railings and standards for stairs that I won't cover, but will be covered later on in the design classes. Then we talk about landings. I already mentioned this before. A landing is required anywhere we have a grade change, greater than 5%. So we have minimum dimensions of 4 by 4. 4 by 4. If we have a 5-foot sidewalk, it would make sense that this be 5 foot. 5 foot. If we did the math here, and this was 2% and this was 2%, this grade would be greater than 2%. It would be 2 times the square root of 2 times 2%, or whatever that would be. And so you can't have 2% vertically or longitudinally and 2% transversely. If I lay my level down, it has to be no more than 2% in every direction. Here's another one. Also, as we're laying out these grade changes, the grade change should happen at a transverse joint location, not only for design, but also for construction. So it's much easier if we have the grade change happen here, 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 and here. Easier to navigate for a person walking through there, and easier to design, and easier to construct. Curb ramp components. I'm not going to talk about this specifically right now until after lunch, but as Brady talks about it in the transition plans, the things that we're looking at are in this diagram here. The gutter. The gutter is a big design challenge through a pedestrian access route because we have to maintain a maximum longitudinal grade of 5%, except through the pedestrian access ramp. There we can go up to 8.3. We have to maintain a maximum cross slope of 2%, except in the flares, where we can go up to 10%, depending on if it's walkable or non-walkable. A non-walkable flare, you're allowed to go up to 1 and 6, which I think, is that 15%? It is, right? Okay. I never announce myself as good math in the head person, but I'm pretty good at those. 1 in 10 is 10%. That one I know. Thank you very much. Okay. We'll talk about these pedestrian signals, how they must be placed and where they must sit in relationship to the crosswalk, the curb, and the sidewalk. Oh wait, I didn't talk about everything. On the MnDOT standards, we also see where the landing is placed, either at the top or the bottom of the ramp. We see the ramp itself, the detectable warnings, and where those are going to be. This is called a flare. Again, it can be walkable or non-walkable, depending on how you might expect somebody to come through here. So, what do you think? Is this a walkable flare or non-walkable?
Walkable.
It's walkable, because you would expect somebody to come through here and think they could cut through there, right? So then it has to have different standards than something where you would not expect somebody to walk. This is the approach panel, and I think I covered everything then. So.
Sometimes those get, especially trying to get all your slopes right.
Oh.
We've had it to where you get it all set up proper, and then you get your smart level, and guess what? You gotta rip it all back out and redo everything. And it's just, the guidelines are so hard.
I know. Especially when you're trying to retrofit.
And then the contractor's getting mad at you because you're like, this isn't gonna work. And they're like, F you.
They go, no, just turn it around and then it'll work. And you're like, well, I can't promise the MnDOT guy is gonna have it in the same direction, right? So we'll talk about that when we talk about the construction part. There's some things you can do, but we get it. We know this is really hard, especially when you're talking about a mill and overlay or somewhere where you're trapped with some grades and elevations. You don't have a lot of play. So 100%. Agree with you. The running slope, I mentioned this before. The running slope is the slope parallel to the wheelchair wheels. So in this example, this is the running slope. We need a landing here if this slope exceeds 5%. Oh no, we need it 2 reasons. If it exceeds 5%, we need a landing there, but we need one anyway because a landing is also required anywhere there's a change in direction. And I haven't said that before. So landings are required where you have a grade exceeding 5%, but where you also have a change in direction. Then through here, this is the cross slope. The cross slope changes, and then the cross slope also runs through the gutter. And that's a maximum of 1 in 48. Again, we use 2% to give ourselves a little bit of fluff. Here's an example of a couple landing options. In the MnDOT standards for pedestrian curb ramps, you'll see landings which may or may not be required depending on which grade is required to get down to the gutter. If that grade is greater than 5%, you need a landing, or if you have a change in direction. So on this one, if this wasn't here and this was 5% or less, there wouldn't need to be a landing, but once you introduce a change in direction, then you gotta have a landing. The reality is because of geometry, more often than not, that initial grade is gonna exceed 5%, but we got a million different options out there in the real world, and sometimes you might have a very flat intersection where you don't have that. You probably at that point also have a change in direction though. So landings are a common element in pedestrian curb ramps. Also, the minimum dimension is 4 by 4, preferably 5 by 5 if you have a full walk width. It would be ridiculous to have a 5-foot walk narrow down to a 4-foot landing into the curb ramp. So we try to match and make sense. So again, the approach is a pavement leading to the top of the ramp. It must be parallel or perpendicular to the curb. Pretty much, I was going to say there's probably some geometric situation that violates that, but that's our overriding principle. The length must be long enough to achieve the height of the curb at less than an 8.3% slope. If you have some weird thing, like here in town, I'm thinking of Summit Avenue, where they have those huge, big boulevards, and down by Crocus Hill, they might actually have a change in elevation such that you need a ramp greater than 15 feet long. That's okay, but you have to have an intermediate landing. So, we got a couple people from St. Paul in here. That was the one example I've been using because most people in Minnesota have been near Summit Avenue. Not everybody's got those big, wide boulevards, but that's one area that I could think of where you may have this situation. Then the ramp width must be at least 4 feet. Then lastly, we'll talk about these detectable warnings, the truncated domes, and where they must be placed. Here's the standards. What they do is they tell a visually impaired person that there's an intersection coming. They must extend the full width of the ramp within 3 inches on each end. Now, when we get into fan ramps and we get into kind of weird directional ramps, there's all kinds of situations where the concrete may extend beyond the pedestrian access route, and Brady will do his best to field those questions. Notice how I told you to ask Brady about it. We get a lot of questions about that because depending on the geometry, you might get some really weird stuff. The rules are that the domes must extend beyond or throughout the entire pedestrian access route. What's the width of the pedestrian access route? 4 feet, right? So they have to extend through that. And if you get a skewed kind of intersection, you may have to put in more than 4 feet of dome. On a 5-foot sidewalk, you put in 5 feet if that's the width of your curb opening. So we'll show you a bunch of pictures and we'll talk those through. They must be at least 24 inches deep in any direction of travel. So the question always comes up, can we cut these up? Can we kind of put them in a weird kittywampus staggered direction? And our answer has been, no, that's not how they're meant to be installed. And so depending on what you have, ask us. You might have some situation that's really interesting and we would all learn from it. They must be placed within 3 to 6 inches of the back of curb. So we see here between 3 to 6 inches of the back of curb. They also come in a radial type of situation. We'll show you the standard plate for that. And the color must contrast with the concrete. They also must be installed correctly so we don't have a lip or any kind of tripping hazard on them. I'm sure you guys are going to have lots of questions because we have fielded many questions about those domes. So please, this is a no shame group, right? There's no judgment here. So if you have a weird thing, we've got a big whiteboard over there. You can draw it out and get a whole bunch of free consulting help today from everybody in the room as to what to do in those weird cases. The flares and curb transitions, they may be walkable or non-walkable. This would be considered a non-walkable because it's in the middle. Clearly somebody's going to go either here or here. Now it's concrete. Can I walk on it? Yes, but I believe this is a 1 to 6, isn't it, Brady? On the nose?
That'd be 1 to 10.
Oh, this one is 1 to 10? All right, well, we got other examples on the edge where we can go up to 1 to 6 with that nose detail. Here we have a walkable flare. 1 to 10 would be the maximum there. Now I'm trying to find one of those nose situations to absolve myself. Here we go. So here we would have a concrete Non-walkable, now again, can I walk on that? Yes, but there's really no reason for me to do that, so we're allowed to go at a 1 to 6 there. Did I say that right? Thanks. Okay. Here we have another situation where it's graded, clearly walkable, but not something that we would expect a visually impaired person to be walking at. That also could be at a 1 to 6. And then also where we have a transition where we choose not to put in the flare, we could put in the return curb or the vertical curb. How many of you have that vertical curb up against any of your intersection, any of your ramps? Not too many.
So how did they get away with not putting truncated domes on the top where they have a vertical curb? Because it's not a true crosswalk or what?
So here's where detectable warnings get even a little more confusing. So back in 1991, the original ADA standards came out. 2 times in the 90s, they removed the requirement to have detectable warnings on a curb ramp. So there's a chance this was installed at a time where they weren't required and are therefore compliant. But they're built or modified today, they need those truncated domes.
I think that's a really big trailer concrete, but it looks like
It does kind of look new. It also could not be, it might be not local, in which case I don't know how they deal with that, but they should meet the minimum national standards of having domes. It could be an old picture, an old picture.
Yeah.
It was a
That's
new
a good
picture at
point.
the time after fresh construction 20 years ago.
So Brady and I,
that's not old, that's a Toyota Solara, man.
using our best CSI technology, we have not been able to analyze that license plate. But we're going to work with the producers of whatever that is, CBS, to do that. So here's something we didn't say in the beginning. It is hard to get good pictures, and so poor Brady, it's been his life's work the last year to find good pictures for this presentation. It's hard. It's hard to find them. Plus, we don't want to put something in there and somebody say, oh, that's my intersection or whatever. So he's done a good job, but good catch. There's no domes there, so we don't know why. But this is a good example of vertical curb. Somebody last week told us for a while vertical curb was like the preferred standard. It's fallen out of favor, so now it's not the preferred standard anymore. So standards change, but we're not going to go out and retrofit every intersection.
Why not?
Why not?
Why isn't it the preferred solution?
So
Brady will answer
I get to
that.
talk about MnDOT twice here. One, a lot of these pictures are from MnDOT, so I'm going to deflect the blame a little bit. MnDOT does not want the return curb unless it's necessary because of plows or other equipment can chip those away. It's primarily a maintenance issue, I believe. It could be a tripping. You need a detectable edge either way, but a curb transition is also a detectable edge.
Well, when your snowplow comes through there, because I worked at MnDOT for a number of years, so when you're plowing, it'll just keep that curb straight off,
Yeah.
That's why they want the tapers and the flares, that way if the plow is getting close, and it'll just ride it and then fall back down and continue down. But,
Right. I think winter maintenance is probably the biggest factor.
right.
Nate, do you have something you want to
That's what I was saying, winter maintenance is a nightmare for
Yeah.
I mean, they're nice for the wheelchairs and whatnot. With the snow and ice, then you're not gonna be bouncing off the sides or the visually impaired. They actually have a true.
Yeah, they got something to hit it.
The vertical curb intersections or cuts like that, especially through pork chops, tend to catch a lot more wind-blown debris also.
Oh, yeah, good point.
Leaves and dirt and crap builds up in those much faster than